Okay, let's do a quick problem here, just practicing adding rational functions. So let's say we want to compute the limit of this function of t as t goes to 0. Well, if we try plugging in t equals 0, we see that we're going to be dividing by 0 in both the first term and the second term. So let's get a common denominator. So if we get a common denominator, first let's rewrite our limit. Our common denominator is going to be, well, that's a good question. We can sort of look at both of these and say, well, I'm not sure what the common denominator should be, but I can always multiply both of them, right? If I just make the denominator t times t squared plus t, that'll definitely be common. So let me show you what I mean there. So I just multiply one by the other. So now if I look at my denominators, let me circle those in green. So the denominator here is going to be the same as the denominator there. And so if I simplify this, it's going to be the limit as t goes to 0 of t squared plus t, so that's our numerator, all over our denominator. And then we have a minus sign, and the second fraction can have that same denominator. That was our choice. And then we're going to have that on top is just going to be t. So now we're ready to add those two fractions. So when we combine them, we're going to get t squared plus t minus t, all with the same denominator, t times t squared plus t. And now I'm going to notice that those cancel. So I'm going to squeeze in another line here. T squared over t times t squared plus t. So if we do that, well, we can cancel one t. You can see that we can cancel maybe that t. Maybe let's do this in a different color. Let's cancel that t with one of those t's there. So we're going to get the limit as t goes to 0 of t over t squared plus t. And so we try, let's plug in t equals 0. Well, we plug it in, we still get 0 over 0. So that's a sign that we still have more simplifying to do. So we have more simplifying to do, and we say, well, oh, I see. I can factor the denominator again. So if I can factor a t out of that, so I get t times t plus 1. I can do one more cancel of that t. And so I get, at the end, the limit as t goes to 0 of 1 over t plus 1. And now I can plug t equals 0 in, and I can plug that in, and I get 1 over 0 plus 1, which is going to be 1 over 1, which is just 1. So this is an example of adding rational functions. Some of you might have noticed, wonder what would have happened if we had maybe factored it earlier on in the process. So let's actually see what happens there. Let me just erase all this. So another way we could have done it is to say, well, first thing I'm going to do is I'm going to factor this, and I get t times t plus 1. Rewrite my limit. And now when I look at this, I say, aha, I can get a common factor that's just going to be t times t plus 1. So I just need to multiply the first thing by t plus 1 over itself. And then my second term already has that denominator. If we do that, now we get one big denominator that's t times t plus 1. Our first factor had a t plus 1. Our second factor just had 1. And we see that those 1's cancel. We get now t over t times t plus 1. And now we can see that we're back in sort of familiar territory from the first way we solved it. We're going to have the limit of 1 over t plus 1, which is 1 over 0 plus 1, which is 1 over 1. So we saw two different ways to solve this. The point of doing this problem in two different ways is to show you that even if you choose a different common denominator, you can still get the correct answer at the end. So thanks for watching, and let me know if you have any requests, and comment on these videos if you have any questions. Thanks.